guys ready? Formula sheet. You need to go ahead and add your last two formulas, which should be numbers 8 and 9, correct? So you have surface area for a sphere and volume for a sphere. And you already know what those formulas are. Surface area, one more time, is going to be 4 pi r squared. And then surface area, or volume, excuse me, is going to be 4/3 pi r cubed. So the pi r squared and pi r cubed part ought to be pretty easy to memorize, thinking about area versus volume. And a circle is always pi r, so that kind of helps. But keeping straight the 4 and the 4/3, the way I remember that is they're both going to have a 4. And the other formula for volume we have also has a third, the 1/3 BH for pyramids and cones. So I keep the 4/3 with the volume formula. Or the one with the cubed that has a 3 also has the 3. So maybe that'll help you keep them straight. Okay? So I'm not going to go through in the notes and show you the long proofs of how they've discovered these formulas. But if you are curious, I went ahead and put it in the notes. So if you look at your notes, the first thing you're going to see is obviously the vocabulary, which we just kind of reviewed with the vocab review. So I'm not going to go back through all of that again, but all of those vocabulary words we just talked about, we reviewed when we did the practice. Are you guys good with a great circle, a hemisphere, a radius, a center? Any questions about that? When you look at the sphere that I actually have in class, you can see the great circle very obviously. It's that bright neon circle, and the reason it's called a great circle is because it is the cross section that would have the greatest circumference and area. If you were to slice the sphere anywhere else, the cross section would be smaller, a smaller circumference, a smaller area. So it is the greatest. On the world, what is the great circle the same as? Equator, okay? And the equator divides the Earth into 2 hemispheres. So we do relate that back to our planets. Okay. So again, this is where you're going to see the development of your formulas. And you can go through and read that and look at the work here if you would like to see where they came up with 4/3 pi r cubed. But it's kind of a complicated process, so I'm not going to take the time to go over that. And then the same thing for the surface area. I included it so you could see it. And if you're curious, go through and follow that proof. But this is how they came up with the 4 pi r squared. Okay? I would much rather though spend our time practicing using those formulas today and give you some time to work on your homework, because I have bombarded you with a lot of homework this week. So today's assignment will be 1 core math page front and back, and hopefully you'll have about at least 30 minutes, maybe more, to go through it. Okay? If we can get through these notes. So participate, help me out, and we'll go through it a lot faster. I'm only going to work the ones that I feel like we need to work, but if I don't work one and you say, wait a minute, would you do that? I'll be happy to do it, okay? So look at this problem. The only thing you need today to find surface area or volume is what measurement? The radius. If you know the radius, it's just a matter of plugging it into the formula and solving it. So when you look at this picture, what's the radius? 12. I'm not going to work this one then. You know it's 12, you can plug it into the formula. Is that okay? Okay, we'll get some practice in a minute, but that's an easy one. So I'm going to skip it. Let's go to this one. It says find the diameter of a sphere with a volume of 36,000 pi centimeters cubed. Let's work this one. What do we want to find? Diameter. What do they give us? Volume. Be careful you don't miss the pi. Sometimes students don't see that pi and that messes up everything. So be very careful. It's 36,000 pi. Okay, what would we do to work backwards to find the diameter? Okay, write out the equation. What do you mean by that? So I have 36,000 pi for V. You mean replace it for V in what? the volume formula, okay? So we need to plug in our volume formula. So we have 4/3 pi r cubed equals 36,000 pi. So the hardest part today is just going to be working backwards on the formulas or your composite shapes where they combine a sphere and a cylinder, prism, pyramid, cone, okay? All right, so what would we do here to solve for r? Divide by pi. What else? 4/3. And you can do that all at once, or you can do that separately. You're going to end up with r cubed equals, what's going to happen to those pi's? They're just going to cancel out. And what is 36,000 divided by 4/3? What is it? It's not 3,000. 27,000. When you type it into your calculator, be careful that you're doing 36,000 divided by 4/3. Which technically will turn out to be the same answer. It shouldn't affect you too much here, but to get 27,000, everybody? Okay? Josh, you good? All right, what do we do from here, guys? Cubed root. Where's the cubed root key? Under math. So you're going to take the cubed root. What is the radius? 30. Everybody remember where to find that cubed root key? Math number 4. So my radius is 30, so what does that make my diameter? 60, because it's twice the radius. So 2 times 30 gives me 60 what? Centimeters, and it's just centimeters, right? Not squared, not cubed, it's not area, it's not volume. Easy enough? Ask now if you have a question, please. Okay, moving on. So on this one, it says find the volume and surface area of a hemisphere. This doesn't seem very difficult when you first look at it, but we need to talk about the surface area because that's where I see mistakes. So we're going to go ahead and work this one. If I want to find the volume of a hemisphere, what am I going to do different once I find the volume of the sphere? Just divide by 2. So volume equals 4/3 pi r cubed. And we're going to take that and divide it by 2, which is the same as multiplying it by 1/2. Now you could do this in the formula before you actually plug anything in if you want to. You don't have to. What would this reduce to though? Half of 4/3. Because it's 4/6, which would be 2/3. So if you wanted to memorize the volume of a hemisphere, it is 2/3 pi r cubed. You do not need to memorize that. You can just find the volume of the sphere and divide it by 2 at the end, and it's totally fine. Okay? So either way you want to think about it. Plug it in. What's our radius? 15. So you're going to cube 15. What is 15 cubed? 3,375. And you're either going to multiply that by 2/3, or if you were doing it the original way up here, you would multiply it by 4/3 and then divide it by 2. Are we good? Did I confuse anybody here by going to 2/3? Okay, so this is going to be 2/3 of 3,375, and we still have the pi. And so what is 2/3 of 3,375? 2,250. What am I missing? Pi meters cubed. Questions? We went pretty quickly through that. Okay, let's talk surface area. Surface area of a hemisphere. If all you do is find half the surface, all you're finding is this bottom part. But when you look at a hemisphere, what else is on your hemisphere? The great circle on the top. So when you're talking surface area of a hemisphere, you have to not only include this bottom surface, which is half of the sphere, but you have to add in the great circle's space on top. Does that make sense? For real? Everybody's with me? Okay, so when we do the surface area of a hemisphere, you're going to do half of the sphere. What's the formula for half a sphere? Or formula for a sphere? Pi r squared. Okay? What's half of 4 pi r squared? That's 2 pi r squareds. But that's just this bottom part. And we need to add in the area of the circle on the top. What's the formula for the circle on the top? That's circumference. Pi r squared. So then we need to add in the area of the circle on the top, which would be another pi r squared. So what is the surface area of an entire hemisphere? 3 pi r squareds. Now, again, you don't have to memorize that formula. You could just do half the surface area of your sphere, find the area of your circle, add them together. Or you could just do 3 pi r squared. Are we clear on the concept as far as the process? Aren't you good? So what's the radius? 15, so let's plug it in. Surface area equals 3 pi times 15 squared. 15 squared is 225. So what is 3 times 225? 675 pi. Is that correct? Everybody good with that? What are my units? Meters squared. Okay, so again, don't get caught up in having to memorize 3 pi r squared. Just do half your sphere, add in your great circle. Okay, we're going to talk about this one, but I'm not going to work it unless you need me to. Take a minute and read this. JP, focus. Okay, so it says you have 2 size exercise balls. You have a jumbo and a standard. They're asking you to figure out how many times as great is the volume of the jumbo ball than the standard ball. How are you going to calculate how many times as great? Exactly. This work should be easy to find the 2 volumes, but what you have to do after that is figure out how many times is great. So you need to take the volume of the jumbo and divide it by the volume of the standard. And that's going to give you how many times as great it is. And then I would expect a complete sentence. The volume of the jumbo ball is blank times as great as the standard ball. Is everybody with me? Okay, make sure you're writing a complete sentence on your homework if you have one like this. What's the only thing you're going to have to do before you can find their 2 volumes? Find the radius. So what is the radius for the standard? And what's the radius of the jumbo? Okay, so you can do that volume work. I'm not worried about that, but just make sure you know to do the whatever it says. How many times as great is the bigger one versus the smaller one? So divide bigger by smaller. Are we good? Okay, moving on. This one is another one that we're going to have to work backwards, so we'll set it up. If you need me to work it, we will. If you don't, we won't. What are they giving us here? Surface area. So if they tell me the surface area of the sphere is 324 pi, what are we going to set that equal to so that we can find the volume? The formula for surface area, which is 4 pi r squared. Can you work it from there to find the value of r? Divide by 4 pi. And what do you get? 81. So what's the radius? 9. And then from there you can plug that in to find the volume. Is that okay? So I'm going to stop just so I don't waste time and give you time to practice. Okay? So then I'm just going to put plug into volume. Keep going. And again, these are filled out in the notes, so if you want to check anything, you can look at the filled in notes. Okay, what is different on this one? What are they giving you here? The area of the great circle. So now they want you to find volume and surface area. Again, all you need is R, but they're giving you the area of the great circle. So what formula will you plug in there? Just pi r squared, because it's just area of a circle. Does that make sense? So you'll plug in pi r squared and set it equal to 49 pi. Go ahead and work backwards. What are you going to get for the radius? 7. Divide by pi. R squared equals 49, so R is 7. And again, you would just keep going and plug it into volume and surface area. Is it okay if I don't keep working? Everybody's okay with working backwards? Okay? On the next one, this just goes back to what we've been talking about over and over again with our shortcuts. If all dimensions are multiplied by A, what happens to the volume? It's multiplied by A cubed. In our formulas today, what's the only dimension that we have? The radius. It just goes in all directions. So if the radius is multiplied by 3/4, all dimensions are being multiplied by 3/4 because it's the only dimension that it has. So your answer would be a complete sentence. The volume is multiplied by, very good. Make sure that you do cube that 3/4. And when you cube that, remember you can just cube the numerator and then cube the denominator separately. So 3 cubed is, and 4 cubed is 64. Good. So the volume is multiplied by 27/64. No work to show. There's your answer. Questions there? Okay. Last question you should see on your notes is just the composite shape. Let's talk about it. Again, I won't work it unless you need me to. Sphere and cylinder, but how much of the sphere do we have? Half. Okay, everybody look up here with me. So let's talk volume. What are you going to do to find the volume? On this problem, what are we going to do to find the volume? Okay, volume of the cylinder and hemisphere and add them together. So what formula are you going to use for cylinder? Base times height, not 1/3. Remember, cylinder is just capital BH. Plus, you're going to find the volume of the hemisphere. Okay, so capital BH plus, what's the volume for the hemisphere? And if you don't remember 2/3 pi r cubed, just remember to do half of the volume of a sphere, which is 4/3 pi r cubed. But that does turn out to just be 2/3 pi r cubed. Look at your formula for capital B. What's the area of your base of your cylinder? Pi r squared. So this will be pi r squared h. What's the radius in the picture? 6. What's the height in the picture? 9. So from there, I know you can find the volume and you have the radius for the hemisphere, because if this is 12, the hemisphere's radius is also 6. Are we good with volume? Questions from anybody? All right, surface area is the hardest part, so make sure you're looking up here. On the surface area, what are we not going to need for the cylinder? The top base. What's the formula for surface area of a cylinder? Okay, pH plus 2b, right? But we don't need what? One of the bases. So could we just change this to pH plus 1b? Okay, and then the top part is a hemisphere, but be careful. On the last problem we did, we had to include the great circle. Our hemisphere is sitting on top of our cylinder, so do we need the great circle? No. So you'll just do half the surface area of the sphere. What's the surface area of a sphere? 4 pi r squared. And so you're just going to do half of that, which would just be 2 pi r squared. Any questions about surface area? Any questions about spheres at all for the notes today? Okay, that's it. I told you today was easy. The last couple days have been brutal. You